Last page of the pretest here. We got this. We just have to find the things that make this side equal 0. Basically, that means either this can equal 0 or this can equal 0. So for this to equal 0, x has to equal 0. And for this to equal 0, x has to equal 11. So the way you'd write it on the test is x, where x equals 0 or x equals 11. Let's try number 2. That's y plus 8, y minus 2 equals 0. Looks like x is going to be negative 8, or x is going to equal positive 2. So for this one, it's x, where x equals negative 8, or x equals positive 2. That's number 2. There shouldn't be any problem. Number 3, 2x minus 6, 5x minus 1 equals 0. You can just figure out what would make this equal 0 and this equals 0. I'm not going to do the math, but 2x minus 6, this would be, x would equal positive 3, or x would equal positive 1/5. If you saw this as a GCF opportunity to take out a 2, let's try that. So we take out a 2, and then we get x minus 3, and we get 5x minus 1, same there. 2, you can think of it as not part of the problem, because if you divide each side by 2, 0 divided by 2 is still 0, so that goes away. So x minus 3 and 5x minus 1 have to equal 0. So it's going to be x equals 3 and x equals 1/5, the same as it was before. So if you GCF that out, it shouldn't hurt you at all. So these are our answers. I'm not going to write that notation, but x is 3 or x is 1/5 for number 3 on page 3. Let's look at number 4 on page 3. That's x squared minus 14x plus 48 equals 0. Looks like we're going to have to factor this as a trinomial. Think of it as grouping, but just use the CAST method, which is very similar to grouping. It just takes out steps. So we need to find something that multiplies to positive 48, adds to negative 14. How about, see, 4 and 12 won't work. How about 16 and 3? That won't work. How about 24 and 2? That won't work. How about 3 and, we already tried that, 3 and 16? That won't work. Let's see, what do we got here? So we got 1 and 48, that won't work, or negative 1 and 48. We got 1 and negative 48, that won't work. We got 2 and 20 and negative 24. We got negative 2 and 24. We got 3 and negative 16. We got negative 3 and positive 16. We got 4 and negative 12. We got negative 4 and 12. We got 6 and negative 8. I'm sorry, these are all negatives here, because it has to equal positive 48. So this looks like we finally got it, negative 6 and negative 8. So I'm going to rewrite this as x squared minus 6x minus 8x plus 48 equals 0. I'm going to group these. I'm going to get a GCF of x here, so I get x minus 6. I'm going to GCF out a negative 8, and I'm going to get x minus 6 here. Again, I changed that sign. So I factor out an x minus 6, factor out an x minus 8. Well, wait, I'm not done, because I have to remember to set it equal to 0. So it looks like my answers are going to be 6 or 8, both positive, because they have to make these two things equal 0. So that's number 4. Let's look at number 5, page 3. We have r squared minus 6r equals 27. Can't do this any other way than subtracting 27 on both sides, setting it equal to 0. If you have an r squared and an r on the same side, or in the same problem, you're going to have to solve it by factoring at this point. So again, this is a trinomial with no coefficient here. So the easiest thing to do is just to think of what multiplies to negative 27 that adds to negative 6. I'm thinking negative 9 and positive 3. So all we do is write those and then put our r's here. That's going to equal 0. It looks like r is going to equal 9 or r equals negative 3. Those are our final answers for that. Let's look at number 6, page 3. M squared equals 81. Don't think that you can just put a 9 in here and get it, because there's going to be a negative answer too, as you'll see. So let's subtract 81 on both sides. So we get m squared minus 81 equals 0. This is a difference of two perfect squares. So I get m plus 9, m minus 9 equals 0, which means x can equal negative 9 or x can equal positive 9, or just 9. The way you might learn it later is there's two ways to do it. You can say x equals positive or negative 9. You can also say, yeah, that's probably the best way to say it. X equals positive or negative 9. You could leave it like this too. It doesn't matter. Either of those ways work.